Humble ourselves for prayer. Our Lord Father, we thank you so much for this opportunity. We thank you for this great honor to have this seminar at such a time. We pray that as we learn and as we get to share different things, we're able to understand different concepts, Lord. We call upon your presence in this meeting. We pray for understanding and wisdom. We pray that we may not leave here without anything, and we pray that all schools and individuals may be impacted through this seminar. I pray this, believe in your Son, Jesus Christ, our Lord. Amen.
Okay. Thank you so much, Isabel, for the word of prayer. And I want to welcome all the schools that have joined in. Thank you so much for joining the session. I'm going to share my screen briefly and then, okay. 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 Now, submath as a paper, submath as a paper, we shall have two sections in that paper, section A and section B, and the paper will take 2 hours and 30 minutes. The paper has 6 items in total. When you combine section A and section B, we shall have 6 items in total. And among these 6 items, we shall have 2 items that are going to be compulsory. Now, these 2 compulsory items are going to be coming from 2 sections that you must have mastered very well. And then, in total, you are going to be doing 4 items within the 2 hours and 30 minutes. Now, how is the structure? Now, when it comes to section A is going to have majorly 5 topics. But the first section is what we call geometry. And under geometry is where you learned vectors, is where you learned your trigonometry. That is the first. Meaning that when they are setting an item can have vectors and trigonometry combined. But also an item can come when it has just one part, let me say vectors, or when it has what? Trigonometry only. But when you are approaching this section, you need now to know, do I know how to find angles? Do I know how to solve trigonometric equations? Because those are the major things. Then the second number is about calculus. Calculus is where you learned about differentiation, integration, and differential equations. Now, this is one item. You're going to be finding one item, but that one item will involve the issues concerning differentiation, integration, and then the differential equations. Then when it comes to section B is going to have also 2 parts. But the first part is the one containing numerical concepts, where you looked at things of indices. It has quadratics, where you looked at how to solve quadratic equations, where you looked at alpha, beta, how to form quadratic equations. That is quadratics. Then we have permutations and combinations, where you looked at things concerning arrangement of things whenever you have any given data. Then the other one, the series, where you looked at APs and where you looked at GPs. But those are the things you're going to find under algebra. Then the second part is the one that contains matrices. So under matrices, this is where you looked at how to use matrices to solve equations when you have 3 variables. Here, you looked at descriptive statistics, things of mode, mean, median, and the rest of that, quartile, and the rest of that. Then you went on and looked at correlation and scatter diagrams. You looked at how to use the graphs to estimate things. This is where you looked at the Spearman's rank correlation coefficient. Then we have what we call probability theory, and under probability theory, you looked at condition probabilities, you looked at tree diagrams, then you went on to random variables, probability distribution, and then the time series analysis. Now, those are the topics, and that's how your paper is going to be structured. What does it mean? It means that you must prepare very well for your paper. You must be well conversant with all the sections because you must do a number from here, you must do a number from here, and you must choose one item from here, and also you must choose one item from that section. Now that is how the paper is going to be structured. Okay, so we are going to continue. Now, how are we going to plan? Planning for the paper is very important because once you do not plan, it means that you may find challenges completing the paper on time. Now, the first thing you have to do is that once you receive your paper, first scan through and check out which number am I going to start with. You scan through all the items that have been given for the first minutes. Like let me say you can use 5 or 10. By scanning through, you are reading through to identify which topic, what approach will I use, and then after you are going to make a decision that now which item am I going to start with. Now, I want to always encourage you that I want to ask you that always, whenever you receive your paper, always start with the item that you are well conversant with. The item you feel you are very confident that once you start this item, everything is going to come out very well. Don't say that the item has number 1, number 2. No, for you start with the item you feel you are well conversant with. Then I want you always to analyze. The moment you identify that I'm going to start with item number 1 as your first item, I want you to go on and now start with identifying that where is the mathematics in this scenario. Then identify the math. Which formulas will I need when I am approaching this item? Which methods am I going to use to be able to come up with a solution? So for each of the items you are going to do, I want you not to spend more than 30 minutes on that item. So for each of the item you are going to do, whenever you are planning, ensure that at least that particular item you are working on, you use less than or equal to 30 minutes. The moment you find yourself that you are spending more than 30 minutes on just one item, it means that chances are high you are not going to be able to complete the paper. So the moment you see that you are taking 1 hour, you are still on one item, then it is an indicator that the chances are high that you may not be able to complete the paper. So you need to plan better concerning time management. Okay, now how are we going to approach these scenarios? Now, as you approach the scenarios, I want you always to first identify what is the concept. You read through the scenario. Many times the scenarios are going to be giving a clue that this scenario, what is the concept within the scenario. Before you start, you need to first identify the concept within the scenario. Am I going to use quadratic formula? Am I going to be solving something? What is it that you are going to be doing? Then from there, identify the method that you are going to use. Not all methods you have in your head are going to apply. When you look at the scenarios that we are going to discuss, you may have noticed that, let me say one of the items was talking about APs and GPs. Then you have to identify that if the item is about series, which method am I going to use? First, is it an AP? Is it a GP? Now, after you knowing that it is an AP, then you ask yourself, what are they asking for? That they are asking for the general term, they are asking for the sum, they are asking for this and the other. Then you ask yourself, do I know the formula? Do I know the method, the approach I'm going to use? Then look at your output. Before you leave the scenario, ask yourself, does my output make sense? Sometimes I want you to please check out. Sometimes the task may ask you to give an accurate output. The moment they tell you they want something very accurate or exact, then you need to know that there they do not expect you to write maybe very many decimal places or what. That means that there is an answer they expect you to get. But also you reason out, ask yourself, is really this output making sense? Take an example. They can give you to calculate, let me say, the number of people in a school, and maybe the number of people in a school, and you have obtained your answer. Let me say your answer, you have obtained 14.4 as your answer. Then you ask yourself, could this be the accurate output? Because you are talking about people, then you need to know that an accurate output must make sense. So that means that now this one is not true, because you can't have 0.4 people. So that means that the number of people within the institution is going to be 14. Then from there, you have to interpret and make a decision. For each of the item you are going to be doing, you may find that the task is a block task. You may find that the task has been divided into two sections. Let me say part A and part B. But you'll find that the tasks that are block are many. What does it mean? You need to understand the scenario, find out what does the scenario want from you. What do they want you to obtain? What problem do they want you to solve? And therefore, after that, you interpret and then you make a decision. In case this probability, you need to know, how do I interpret probability? That maybe for this particular probability, the moment the probability is above 0.8, which words am I supposed to use? So such things you need to be well conversant with them. But for each of the items, you must respond. You must write a conclusion and make a decision. Where they have asked you to interpret, you go on and interpret. So that is briefly about this particular item. So yesterday and the other day, we shared the items that we are going to be using. I have already shared those items here in the chat, but I will also reshare them again, such that for people who have not yet accessed them, you can access them. But at the moment, I'm displaying them on my screen such that you know which items we are going to do. I want also to let you know that there's some few statements that we added in the on two of the items. One of them, this was one of the things that we added on in the items. Hope you saw it. And then also we missed out Mbarara on number 5. But the rest of the items we are very, very okay. So at this point, we are going to start now our discussion, and you are going to allow me now to invite our first presenter, Isabel, to take us through her presentation. You are most welcome, Isabel. Then I'll ask Wanyange to prepare for the next presentations. Isabel? I have shared the items in the chat. I've shared the items in the chat. So kindly have them
Thank
look
you, Teacher
through.
Stephen.
Okay, go on.
Yes, yes. I apologize for the delay in response. A bit of technical difficulties here, but I'm ready to present. Good afternoon, everyone. My name is Isabel Kembabazinyakato from Taiba International School, and I'll be taking you through the first item under data and probability. So let me just share my screen so that we can begin this discussion. I kindly request that all questions are asked after I finish presenting. If you have what I'll call a burning question, you could maybe type it in the chat so that it's addressed first. once I'm done with the presentation. Thank you. So kindly put a thumbs up if you can see my screen. If you can see my screen, kindly put a thumbs up or type in the chat. Can everyone see my screen? Okay. Can everyone see my screen? Can someone unmute and let me know whether they can see my screen?
Yes, we can.
Okay. Thank you so much, Teacher Steven. So today we'll be looking at data and probability, like I mentioned before. I already introduced myself. My name is Isabel Kembaba Sinyakato, a student at Taiba International School, and I offer subsidiary mathematics. So the first item we have here, I'm going to read it and then we'll go in a step-by-step process on how to answer the different problems presented in this particular scenario. So a retail shop in Kampala City sells t-shirts, pairs of trousers, and pairs of shoes. At the end of every week, the shop owner prepares a business report to guide restocking, pricing, and staff deployment for the following week. However, during a system upgrade, the electronic pricing records were accidentally deleted, leaving only the quantities of items sold and the total sales collected over the three consecutive business days. The available records show that on Monday, the shop sold 8 t-shirts, 5 pairs of trousers, and 4 pairs of shoes, collecting 340,000 Uganda shillings. On Tuesday, it sold 12 t-shirts, 7 pairs of trousers, and 10 pairs of shoes, collecting 660,000 Uganda shillings. And on Wednesday, it sold 10 t-shirts, 4 pairs of trousers, and 5 pairs of of shoes, collecting UGX 380,000 Uganda shillings. The shop owner also recorded the arrival times in minutes after 11:10 a.m. of a random sample of customers over the same period, which is given there as follows. And then, basing on the shop's customer service policy, additional sales attendants should be deployed during the period when most customers. Just a minute, sorry. Yes, when most customers. I don't know whether I've lost my screen. Sorry, let me just. When most customers usually arrive. Before implementing this policy, the shop owner would like to establish the selling price of each product and identify the period during which customers mostly commonly arrive at the shop. Task basing on calculations with justifications provide the guidance needed by the shop owner. So having read the task and the scenario given, we're able to identify that this particular scenario has two problems. The first problem being presented by the retail shop owner and his collection of data, and then the second one in regard to staff deployment and also time arrived. So the first problem we're going to address, so the first objective of this particular task is first identify or to determine the selling price of each particular commodity or product, i.e., identify the exact price of a t-shirt, the exact price of a trouser, and the exact price of the shoes. Then our second objective for this particular scenario is to analyze the customer arrival time using statistical methods. And then the third objective is to, of course, recommend to the retail shop owner the best time for deploying additional sale attendants. So given those three objectives ahead of us, I beg to present or begin my presentation. I request to kindly find a better and quiet environment in just 1 minute. Thank you. Thank you. I apologize for that. I believe you can all hear me. So moving on to my next slide. So the first objective, which was to find the price of each commodity being sold. So we have to first find we have first look at the defining variables, or we have first define the variables required. We're going to let X be the price of one t-shirt, Y be the shirt, pardon me, the price of one pair of trousers, and Z be the price of one pair of shoes. This is all in Uganda shillings because that's what the question provided us with. If it was in pounds, if it was in dollars, we'd also be expected to get our X in dollars, X maybe Y in dollars, and Z in dollars. So kindly be very keen as you read your question and always follow what's required of you. If they give you GX, kindly don't write the numerator in dollars or the value in dollars. If they give you dollars, don't now write it in UGX because you are familiar with writing in your common value. Sorry. So once you have been able to define your variables or let the different commodities to an unknown letter, in this case X, Y, and Z, you're going to start by forming your equation. So if you realize we do have three equations here, one representing Monday, another one representing Tuesday, another one representing Wednesday. So our first equation is a representation of the data collected on Monday, whereby we have 8 t-shirts, 5 trousers, 4 pairs of shoes, which all total to 340,000 Uganda shillings. Then 12 t-shirts, 7 trousers, and 10 pairs of shoes, all equaling to 660,000 Uganda shillings. And then 10 t-shirts, 4 trousers, 5 pairs of shoes, all equaling to 380,000 Uganda shillings. So from that data, we're able to get our three unknowns, or three equations rather, which will help us now progress to the next part of solving this particular problem presented in the task. Okay. So it's better as a student or as a candidate to tabulate your information so that you're able to extract it from the question as you solve it without missing any key points or details. If I'm just to go back, you can realize that I was highlighting the important information in red. It's very important that as you read or unpack the question or the item, you're able to underline the important information so that you don't skip it, or it doesn't skip your eye as you analyze the particular problem presented in the scenario. So just to go back here, yes. So tabulation of information is very important, and as candidates of the new curriculum, we're reminded that every diagram should have a title. So now here, my title is not effective. I just put tabulation of the information, but as a serious learner who intends to get an A in subsidiary mathematics, you also label or title this particular table, which is, you can say, a table showing the data presented in the scenario above, or find a very fitting title for your diagram, because each and every diagram ought to have a title, be it a graph, a table, but yeah, you need to give basically the person who is marking your work an understanding of, okay, why is this table drawn and what's the context of this table, right? Okay, just to progress. So from the table, we're able to now derive a matrix. So we have a 3x3 matrix, which is shown here. We have, just annotate. We have here, so we have the X. So remember, defining our variables, we had X, t-shirts as X, the trousers as Y, and the shoes as Z. So the values for X are here. So we have 8, 12, and 10. So they fall under this particular part of the matrix. 5, 7, and 4. That's why they fall under this particular part of the matrix. And then 4, 10, and 5. That's why they fall under this particular part of the matrix. So we have our unknowns, X, Y, and Z, which are presented here. So this is our X. This is our Y. And this is our Z, which are our unknowns. Then we have the total sales in UGX, which is the 340,000 Uganda shillings, the 660 Uganda shillings, and the 380 Uganda shillings. I believe that's understandable, because the matrices was our first topic according to the syllabi, and everyone of us is conversant with how matrices are formed. So I'm going to progress. Okay. Sorry. Just erase these annotations so that they don't disturb us. Okay. So moving on to our next slide. Okay. So how do we solve, sorry? Okay. Yeah. So how do we solve three simultaneous equations? You can use the elimination method, the subsidization method, or rather, pardon me, substitution method. But according to the new curriculum and the syllabi or the syllabus for the S6 subsidiary mathematics, we ought to know how to apply Cramer's rule to solve this particular equation, these particular equations of three simultaneous equations. Yes, so Cramer's rule is basically a mathematical method used to solve three simultaneous equations, whereby you have three variables in this particular case, or typically X, Y, and Z. So instead of using the elimination or substitution method, this rule intends that a person or a candidate or a learner uses determinants. So for matrices, or the earlier part of matrices, we learned that when you are finding determinant, you subtract the measure, the measured, let me just annotate, okay? So if this is your matrix, and you have 1, 2, 3, and 4. So if we can recall, when we're finding determinant, we get this value, which is the measure diagonal, which is 1. You're going to have 1 times 4 minus, guys, please be very key. not to multiply here. When we are finding determinant, we subtract the major from the minor. This diagonal is the major, and this, where we have the 3 and the 2, is the minor. So we have 3 times 2, okay, which will be 4 minus 6, which will give us -2 as our determinant. So that's just a reminder of how we used to find determinant for those of us that had forgotten or couldn't recall. Just erase this annotation, sorry. So yes, Cramer's rule is based on determinants. If you're able to find or have the knowledge on finding determinants, I believe Cramer's rule will be a piece of cake for all of us, given that this is knowledge that we already have, and it just requires now further application into this topic. So here we have this. We have this matrix, and I rewrote this particular matrix for easier explanation. So we have our A1, which is going to be 8, right? A1x, which is now 8. So this is A, this is a column for A, this is a column for B, and this is a column for C, which is basically represented in this particular picture. But I think I'll progress. Let me use the question to explain it better so that we are not all confused or get challenges understanding this particular part of the topic. So the first thing you do when you're finding or using Cramer's rule is to find the major determinant. Given the matrix that we had in the prior, the slide prior, this slide, we'll be using this particular matrix to find our major determinant. Okay, so moving on here, yes. So to find our major determinant, you do realize it's very hard to find determinant for a 3x3 matrix. So what do? You're going to now break it down, and this is what I'm going to take you guys on, how to break down a 3x3 matrix to find its determinant. So the first thing you should all take note of is the symbols I've written above here. Here we have a plus sign. Sorry, okay. We have a plus sign, a minus sign, and a positive sign. So all the values that fall under these particular signs are either positive or negative. So all these values here that we see under the negative sign will be considered as negative numerals. Pardon me, sorry. This particular value will be considered as a negative. This particular value will be considered as a positive, and this particular value will be considered as a positive. Once you forget to make this a negative value, you'll find your values wrong and you'll find it difficult to find the determinant. So moving forward, when you're finding determinant under Cramer's rule, you're going to have, this is going to be your x, this is going to be your, for easy explanation, this is going to be your y, and then this is going to be your z, okay? So if you do realize here, we have formed 2x2 matrix from the 3x3 matrix. So you're going to have your value of 8, your value of 5, and your value of 4 go outside. So now how do we determine the 2x2 matrix or matrices from the 3x3 bigger matrix? You're going to get upper values are what you're going to consider. Now, for example, when you're considering or deriving a 2x2 matrix from this particular 3x3 matrix, you're going to now look at all the values here, and you're going to put your hand there. For For example, if let's say you have a pen or pencil, you can put it there. Now, I don't want you to look at these two values, which is the 12 and the 10. Now just looking at the 8, okay? The 8, remember our 8 is a positive value. So you're going to write 8 here. So I've written it here. So now, not ignoring 12 and 10 under the 8. So basically, I need you to ignore the two values under the 8, which is 12 and 10. So when you ignore 12 and 10 and the upper values, we'll have 4 values remaining, which are 7, 4, and 10. So this is the matrix I'm going to use to find my first determinant or first part of the determinant. So this is, like I said, this is our major diagonal, and then this is our minor diagonal. Okay. So, given the fact that 8 is outside, you're required to ignore the two values under and the top values. So I want you to ignore 8, 5, 4, and 12 and 10. Okay. So we're going to have 7, 4, 10, 5 to get this 2 by 2 matrix. Okay, so that's how we get this first matrix. So how we get the second matrix, if you realize there's a negative sign before the 5. So like I explained earlier, before you start finding your major determinant, always ensure to place your values above the first values of the matrix. It's positive, negative, and positive. Always remember that the middle values or the values in the middle have a negative sign above them. Please remember this, because once I write a positive here, let's say for example, in front of my 5, it makes all my results or all my workings wrong, which will give me a wrong determinant or wrong value for the determinant. So to find the second matrix that we have here, which is a 12, 10, and 10, 5, we're going to now come here. So where the 5 is here, we're going to put it outside. Okay. So the 5 is going with the value, but just to correct myself earlier, I said all the values under here are negative. The negative symbol only applies here to the 5. Kindly don't write these as negative values. These remain positive unless the matrix itself has, let's say if this 7 was negative, it should remain negative. But since in this particular scenario it's positive, it should remain positive. Negative sign only applies for this particular numerator, which is 5. So when we're deriving the 2 by 2 matrix from here, I'll need you to ignore the first row and the particular column you're working on. Let's say all the numerals under the particular column you're working on. So we can see that 7 and 4 are under the particular column we're working on, which are numerals under a 5, right? So you're going to ignore this. You're also going to ignore the upper or the first row. So we'll have 12 and 10 and 10 and 5. So we'll take values besides the column. So 12 and 10, 10 and 5. If you can recall from the first explanation, when I was using 8 or putting the value of 8 outside, I ignored the values under 8 and I only took 7, 4, and 10 and 5. The same thing with when you're getting the matrix for the columns in the middle. You're going to ignore all the values under that particular numerator and only look at the values beside it, okay? Ignoring the first, the numerals above or the numerals either in between or beside for example, in this case, ignoring the 8 and the 4, okay? So we're going to have values for our 2 by 2 matrix as 10, 12, 12, 10, 10, and 5, which you can see here. This being our major and this being our minor diagonal. So same thing for, let me just clear my drawings. Okay, so same thing for this particular matrix, the last matrix we have here. We're looking now at the value of 4. 4 is positive. That's why we have a positive in front here, right? So we put 4 outside and then create a matrix. So remember, ignoring this particular row, and we're also ignoring this whole column. So the value outside, you're going to ignore the row where that particular value is and the column where that particular value is. So that's why we're going to have our last and third matrix as our third 2 by 2 matrix as 10, 12, 10, 7, 4, which is provided here. So this is going to be our major diagonal, and 10 and 7 are going to be our minor diagonal. So once we're able to derive our 3 2 by 2 matrices from our bigger matrix, our bigger 3 by 3 matrix, we're able now to find the major determinant, because from a 2 by 2 matrix, we are able to attain determinants, like I explained earlier. If you subtract the major from the minor, you're able to get the matrix or determinant for the different matrix. So our first 2 by 2 matrix we have here has 7, 4, 10, 5. So our major diagonal, this one that I've used green to highlight, we have 7 and 5, which remember we're going to multiply. And then we have 10 and 4, which as well we're going to multiply. As we multiply these values, remember the major subtracts the minor. So this is our major diagonal. This is our major diagonal, and then this is our minor diagonal. Kindly take note not to add these diagonals. When you add the major diagonal to the minor diagonal, all your values attained will be wrong, because the principle is the major diagonal subtracts the minor diagonal. Remember, we still have our 8 here. That's why we put this in brackets. Still retaining our 8. The process is to first multiply and subtract, and then multiply the 8 outside the brackets after getting or obtaining the values from subtracting the major diagonal from the minor diagonal. So we're going to do this for all the matrices we have. Like you have seen here, this is the major that multiplies and then subtracts the minor. So 12 multiplies with 5, and we put that in brackets, minus the 10, which is now the minor diagonal, which we put in brackets as well. Same thing for this particular matrix, whereby we have 12 times the 4 and 7 times 10, which we subtract. So if you calculate, so this obviously gives us 35, this 40. So when you get 35 minus 40, it gives you negative 5. But remember, we have 8 here, so we have to multiply it to the negative 5. So moving on to the next bracket, we have 12 times 5. 12 times 5 is 60. 60 minus 100 is negative 40. So we're going to have negative 5 times negative 40, right? Same thing for here. We get the values in here and multiply them by the values outside. So when we, after obtaining all the values here, we add them. It ought to be a multiplication sign here. And we will get our major determinant as 72. Okay? So just so that I don't lose anyone at this particular point, I'm going to entertain 3 to 4 questions, because this is a very crucial points to understand. Once we fail to understand how we obtain the major determinant, it will be very hard for us to be able to attain or get the value of x, get the value of y, and get the value of z. So if anyone needs further clarification, I kindly request for 3 to 4 hands so that we can clear the air and proceed from there. Does anyone require or need any clarification? Have I gone too fast? Yes, Sharia? Yes, Sharia, please talk to me. What's the issue and how can we help you? Is Sharia? We can't hear you. Okay, maybe Shaggy, you could be sharing with us what the matter is as Sharia. Yes. Anyway, Mr. Richard? Yes, Richard?
Method. Yes, madam.
Yes, please. Could I kindly hear your question?
Yeah, I would like you to repeat for me elimination method.
I beg your pardon?
I'd like you to repeat for me elimination method.
Which method? I beg your pardon in the method.
Elimination method.
Oh no, we're using Cramer's rule. So Cramer's rule is an alternative for elimination method and substitution method. So it's what I'm trying to explain in this particular case for our question. Have I answered your question, Mr. Richard? Okay. Kindly type in the chat if you still have a challenge. Yes, read one. Kindly share with us.
Oh, yes, I was asking.
Yes, please.
This is you mean we can use an alternative method from Cramer's rule, like elimination? Because the previous person asked if
They could repeat.
this
Yes,
was.
it's an alternative. Cramer's rule is an alternative for elimination and substitution, but according to the syllabus, a learner of S.6 subsidiary mathematics ought to be able to use and apply the Cramer's rule. That's why I'm taking you through on how to use the Cramer's rule in specific here. Yes, please read one.
Hypothetically asking,
Yes,
if you were
please.
to use a method
Yes.
that is not Cramer's rule, because it is to my belief that this Cramer's rule, we have 3 equations. So
Yes.
how exactly
No,
would
you
I
can
use the other methods?
you can use Cramer's rule for both two 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 equations and also to solve 2 simultaneous equations and also 3 simultaneous equations. But since the particular syllabus or curriculum entails that a learner should know how to use Cramer's rule, I think the best method to use, especially when provided a 3 simultaneous equation, is Cramer's rule, given that they'll be wanting, given that the curriculum expects you to know it and they'll be expecting, they would want to test your application of the rule. Yes, please. But other methods, you can also use the elimination and substitution, but the best method to use, in my opinion, is Cramer's rule because I believe that's what the examiner will be testing when such a question is presented because it's what's in the given syllabus of the curriculum.
That is understood.
Yes, please. Thank you so much. So can I receive another person or that's okay for you, read one?
It's okay for me, but I would also
Okay.
like to ask, are we going to go through like the construct? How are we supposed to answer? What is the structure of our papers? Because that's what I was expecting to learn from this meeting.
I think teacher Stephen will handle that after my presentation. Yes, thank you so much.
Okay.
Yes. Yes, Samsung SM. Samsung SM, Shaggy, and Tare High School. Any of the three of you could kindly unmute your mics and share with us. Yes, please, Samsung SM.
Yes, please.
Yes, please.
For me, my concern is one. Substitution.
I
How
can't
do
hear you. You're
we go
breaking.
this very far? Hello?
I kindly request you repeat yourself or repeat your question rather.
I'm saying
Yes.
elimination and substitution method would be the best methods to use here.
Yes,
Not to
they
use
are, but according to the curriculum, you also ought to know the Cramer's rule to answer such questions. That's why
thank you
I
very
chose the
much.
Cramer's rule to take you people through how to approach such a scenario in case or hypothetically if they're to limit us or limit the students to Cramer's rule in specific. Okay, Shaggy. Shaggy or entire school, kindly share with me.
The question I have is one.
Yes, please.
Specifically, you said that you can use either the Cramer's rule or the elimination rule.
Elimination
So
and
it's
also
fine. Can the
substitution.
question?
Yes, please continue.
So can the question come as in say that they can say that use this or this, or it will come in a way that you have to use your own?
Now that I don't know because I'm not the setter of the paper, but they could also limit you to Cramer's rule because they know most learners are conversant with elimination and substitution, and they might also opt to want to test your knowledge on the Cramer's rule because they know that most of us are more familiar with the other two options of elimination and substitution. So that's why in this particular question, my approach was Cramer's rule so that I could take you through on how to apply it, since it's also a method one can use to obtain responses to a three simultaneous equation. I hope I've answered your question, Tara. Okay, Sharia, I weren't able to get you. I think Sharia will be our last person. If not, Shaggy, whoever is able to unmute first and get the question by. Sharia or Shaggy, kindly unmute and share. Okay, Sherry and Shaggy don't look like online. Yes, Johnny M, could you kindly share with me your question? Jolly, are you online? Jolly, we can't hear you. Your mic is open, but we can't hear you. Okay, I think I'm going to proceed. Jolly, kindly hold on to your question because time is going and I need to complete this particular item. So for those of you who haven't understood, kindly write your questions down. There shall be a question segment. I just wanted any questions for this particular step because it's very, very crucial in understanding Cramer's rule. Once you fail to get the major determinant, it's very, very, very difficult for you to get your value of X, your value of Y, and your value of Z. So now, assuming or in assumption that the majority of us have understood how to find our major determinant. I'm going to proceed on how we can find the value of x, y, and z. So kindly, I need at least 3 thumbs up for me to proceed. Has everyone understood how to find the major determinant? Kindly, okay. Seeing from Whitney. Let me see. Kindly react or okay, thumbs up, I'm seeing. Okay, so I'm going to proceed in assumption that all of us have understood how to derive 2 by 2 matrix from a 3 by 3 matrix or a 3 by 3 matrix, yes. So proceeding to my next slide, we're going to look at how to find the value of x, which is very, very crucial. Sorry, let me just minimize this. Okay. Okay, so let me just clear my annotations. Just a moment, guys. I apologize. Let me clear my screen. Infinix Hot 10, kindly table annotation ability. All right, so here we are, represented to finding x, and I believe most of us are now seeing new values in the x column, right? So now most of you, I think, are asking yourselves, where has she gotten these values from, and why are those values where the x values are supposed to be? So one thing we should take note of is that when we are finding the value of x under the Cramer's rule, we're going to place the, let me just to take us back. Okay, so remember we had this, just annotate. Okay, remember we had this. Okay, so here we can see these are our x values in under one column. These are our y values under one column, and these are our z values under one column. So now, in the event that we're finding x, which we are, we're going to replace the d. Now this is d. Okay. If you just look at the picture here we had a, here we have b, and here we have c. Okay. So we're going to replace the values under the d where x is, which is basically the totals for each let's say t-shirt, pair of shoes, and trousers. So the totals, all the total values are going to be replaced where x is. Okay. Kindly take note of that. It's very, very important, because once you place these particular values in the wrong column, you're bound to get wrong answers. So when you're finding x, you put these values in the under the x column. When you're finding y, you're going to put these values under the y column. Okay. When you're finding the z values or the z values, you're going to get these totals and put it under the y column, i.e., you're going to forget about the 8, the 12, the 10, and you're going to now put 340, 660, and 380,000. Okay, I believe that's clear. So just to progress, clear all my drawings to the okay. So to find x, I was explaining earlier, you're going to get the values of x and replace them with these, which are now the totals, okay? You're going to replace the values of x with the totals here, which is now 340, 660, and 380. Now the other values are going to remain, the y and the z values, okay? So with those particular values, you're going to be able to find the value of x. So how do we find the value of x even before I go into the explanation? You're going to first start by finding the determinant of x using the particular method or the particular approach I've explained on finding the major determinant. That's why it was very crucial on us understanding how to find the major determinant, because the same theory or the same knowledge applies to finding the determinant of x itself and the determinant of y, the determinant of z. So at this particular point, again, I'd like to ask, did everyone understand how to find the major determinant? Should I repeat? Because it's very, very, very crucial in our understanding on how to define the determinant of x. So let me just look at yes, Sharia again. Sharia, yes, please, kindly unmute.
Good afternoon, madam.
Yes, please, Sharia.
My question is,
Yes, please.
I didn't understand this method before.
Of the Cramer's rule? The Cramer's rule on how to find the major determinant? Okay. Atiang Mary? She has gone off. Yes, Sherry, are you still there? Okay, looks like she's gone off. I don't know where Atiang Mary went, but just to recap for Sharia and for those who maybe could be there and are scared to raise up their hand, I'm going to repeat on how we find major determinant, because this is a crucial method used when finding values for x, y, and z. Okay. Just a minute. Okay. So for all of us who have not understood, and even for those who have understood, okay, maybe I could get someone here to explain how they have understood it. Maybe someone is just understanding my explanation. Let me see. Before I proceed, yes, Jelly. Jelly, kindly unmute to ask a question. Okay. Atiang Mary, kindly unmute, ask your question. Okay, just to check if all of us are on board and if all of us are following, I'll just like one school or one individual to re-explain for Sharia and for maybe those who haven't understood, given the explanation of given or given what they know about major determinant, briefly without going so deep. Yes, Celia, can you share with us, unmute and share with us an explanation of, from what you've understood, just a recap for Sharia and friends. Yes, Ntare.
It's like when we are trying to determine the major determinant.
Yes, please.
The first values on the matrix given is the one that you use for the first, which is x. We use a positive sign. For the next one, which is y in the middle, we use a negative sign. Then the last, which is z, we use a positive sign. But if you are getting the major and the minor determinants, or diagonals, you remove the figures below the main figure, which is like 8, 12, and 10, we don't use them. Then we consider 7 and 4. Then on the other side, we use 10 and 5. Then if you are on negative 5, we eliminate also it is the figures below it, which is 7 and 4. And we use 12 on the side of 8, 12 and 10. Then also the other side, the last figures, which is 10 and 5. Then if we are handling positive 4, we also eliminate the figures below it. Then we use for the first, which is 8, and then we use 12 and 10, and the next, which was for negative 5, which is 7 and 4. Then we get the major determinant, major diagonal minus minor diagonal. Then we get the value. Thank you.
Linda, oh.
Okay. Thank you so much, Intare High School. I hope Jolly and her friends have understood. Yes, read one. You have a question. Kindly unmute.
I also just wanted to supplement on the Cramer's rule, just to throw more light onto it. To those that haven't understood, the numbers that we see on the first row, 8, 5, and 4, as it has already been clearly explained, we attach signs to those numbers. As you see, the plus on the side and the negative in the middle. So when you're working out, those are the numbers that you're going to put outside of the brackets. So for example, if we're starting with 8, we don't put any number in the brackets from that column with 8. So in this case, we shall not pick 12 and 10. And we shall not pick 5 and 4. We shall then consider 7, 10, 4, and 5. So what shall we do? We shall put 8 outside, and then we multiply like we're getting a determinant. We shall say 7 times 5 minus 10 times 4. That is what we do for negative 5, and that is what we do for positive 4. And to note, if, for example, inside the matrix, 5 was negative, in this case, that 5 would become positive. It will not remain negative 5 because a negative times a negative becomes a positive. Thank you.
Thank you so much, Ridwan. Thank you so much for your submission. I don't know that Celia can unmute and ask her question, but we haven't been able to get to her. So I'm just going to ask that we proceed. Now that I believe everyone has understood, given that we have had our own friends and our own peers explain the concept to us. So, okay. Yes, Ridwan, your hand is still up. Do you have any further supplementation? Oh, okay. I believe everyone is set to proceed. So now we're going to find x. So how do we find x? Let's stop this. By finding x requires us to first find the determinant of x and then divide it by the major determinant, which I've already attained as sorry, I apologize. I was getting a quieter environment. For us to find the value of x, we have to first find the determinant of x and then find the determinant of, and then divide it by the major determinant which we have attained. Remember the major determinant we have gotten is 72. So after attaining the determinant of x, we ought to divide the determinant of x by now the 72 in this particular scenario. So the method or the approach doesn't change when you're finding determinant of x. It's still the same method. The only thing that changes is now that the values that are supposed to be in the x column, like I explained earlier, are going to be replaced by now the totals or the numerals, or rather the, now in this particular case, the total amount of shillings, which is the 340, the 660, and the 3,800. Okay, so now the other numerals for y and z remain the same. Now we know under the y column, under the y Here's the y column. We have 5, 7, and 4. It remains the same. 4, 10, and 5 remains the same. The only thing that's going to change now are the values under the x column. We don't forget, remember what I told you to note, and to crucially note that the symbols or the signs remain the same. A positive, a negative, and a positive. Now remember, we can't find determinant from a 3 by 3 matrix. So what do? We break it down into a what? A 2 by 2 matrix. So for this particular scenario, I had not written anything beside it because I wanted us to go step by step on now how to get or to derive a 2 by 2 matrix. Now when we have changed or replaced the values here for x. So now, of course, we're going to have this particular value outside. But remember, since there's a positive sign above it, it's going to be a positive 340 to 340,000. Okay? So 340,000. Okay? So now we're going to derive our 2 by 2 matrix. Remember, I told you we ignore the values in the row and column where the value outside is. Now, if the value outside is 340,000 Uganda shillings, we're going to ignore all numerals for that particular row and all numerals for that particular column, i.e., all these numerals for this particular row, we're going to ignore them, and then all numerals for this particular column, we're going to ignore them. Okay? So now, which leaves us with with 4 numerals, okay, which are 7, 4, and 10 and 5, which are going to come and write here. Okay, so it's going to be 7, 4, and 10, 5. 5 is okay, but you guys understand. So remember, when we're finding determinant, it's major minus minor. So remember, this is our major, and then this is our minor. So from here, we know that 7 times 5 is 35, which we have here. And then 4 times 10 is here. But people, please, and please don't forget, it's a negative sign. We subtract the major from the minor. Please don't make a mistake and add, divide. Just remember, subtraction. We subtract the major from the minor diagonal. Because once you make a grave mistake of putting a plus here, everything that you calculate will be wrong. You'll fail to find the right value, and this will probably frustrate you in the exam because, of course, once you're unable to find right values, it affects how you attempt other questions. Okay? So please, and please remember, it's subtraction. We subtract the major from the minor. I believe I've put enough emphasis on that, so I'm going to proceed. So now that we have been able to derive our first 2 by 2 matrix from the 3 by 3 matrix, we're going to proceed to the next matrix derived. So here, this is what we have here. Okay, remember the 5, just to clear my annotations. Okay, remember the 5 we have here is negative. This negative symbol only applies to these 5 people. Please don't come and write now -7, -4. No. The negative only applies to the 5 in this question. It only applies to the numeral that's under it. One numeral. Let's say if it were 10 that was in the place of 5, it will be -10. So now that we have -5, we're going to be able to derive our second 2 by 2 matrix from this 3 by 3 matrix provided for us for x. So now, remember, we ignore all values here and here. As long as that particular numeral is in that particular column or row, you're going to ignore those values, right? So remember, we have our 5 outside here, but it's a negative. Please don't forget to add that negative sign to that numeral. If 5 was a -5, let's say the 5 inside here was a -5, and also the sign up here was 5, that's when it would become a positive, because now we'd have -5 minus -5, and remember, a negative and a negative gives us a positive. But in this scenario, since our since our 5 is a positive, it's going to become a negative, because a negative times a negative gives us a negative plus a positive gives us a negative. So this negative 5 comes outside. So now we're going to derive our 2 by 2 matrix. Okay. So we now have, remember, we're ignoring values that are in this column and values that are in this row. Okay. So we're going to now have, let me just widen the matrix here. Okay. So we're going to have now 660,000. All right. And then we're going to have 380,000. Okay. So remember, we're ignoring the values here and the values here. Please don't come and write 7 in this particular matrix, because now we're handling values of, okay, the top numero up here. Let me just clear here. Okay. Sorry, just to clear here a bit, because remember, we're finding our second matrix and the 5 is outside, so we ignore these particular values and these particular values. So we have 660, 380,000, and 10 and 5 here. 10, 5, which we have here. Remember, it's major minus minor. Okay? Yeah. So just clear all my drawings. I believe these two, you now understand how they come into place and where they come from. So same thing for the last 2 by 2 matrix derived from the 3 by 3 matrix. We have now values from this column. Remember, when the 4 is outside now, positive. Positive 4. So we're ignoring all values from here under the 4, and all values are beside or in front of the 4. So now we're going to have 666. And then 380. And then 7, 4. So, like I explained earlier, the major minus the minor, which we now have here. I believe that's all clear. Kindly put a thumbs up or react if I can proceed to now further explanation on finding determinant x. Is that clear for everyone? Kindly just react in the chat or put a thumbs up. There's a burning question. I'm willing to address one burning question prior me proceeding. Okay, I'm seeing a thumbs up, so I believe everything is understandable and clear for everyone. Okay, so just to clear my annotations here. So now once we're able to derive this from the 3 2 by 2 matrices, we'll get our answer. Let me not rush. Let me get there. Okay. So I think I've already put emphasis on the symbol here and how it comes about here. So 35 minus 40 is negative 5. Okay, but remember we have 340 outside here. So we're going to multiply the 340 thousand Uganda shillings, or 340,000 times a negative 5, which is going to give us negative 1,700,000. Then here we have negative 5 into brackets, 660 times 5 minus 10 times 380,000, close bracket. So 660 times 5 is 3,300,000 minus the 3,800,000, which is good for multiplying 10 times the 380,000. Now we're going to subtract these values and then multiply them by the negative 5. Remember, the 5 is negative because of the symbol above it. So from that, we're going to get our answer as 2,500,000 Uganda shillings. So for the next part here, we have 4 outside the bracket, and then into brackets, we have 660,000 times 4 minus 7 times 380,000. So that's going to give us 2,640,000 minus 2,660,000. When we get the value there and multiply it by 4, we'll get 80,000. So when we add the 1,700,000 to the 2,500,000 minus the 80,000, we get our first answer as, or the determinant of x as 720,000, which is now the determinant of x. This is not the value of x, but this is the determinant of x. Now to find x itself, how do we get x? Which is what we are looking for in this particular scenario. You're going to now get the determinant of x, which we have just found as 720,000, and then divided by the major determinants, which we had gotten as 72. So it's going to be determinant of x out of major determinant. This is now major determinant. Let me just write MD to stand for major determinant. Okay? So it's going to be 720. But we already have it here, so okay. It's going to be 720 divided by 72, which is going to give us 10,000 as our x. So we know that the price for that particular commodity of x is 10,000. Is that clear for everyone? Kindly put a thumbs up if you have understood, and if I can proceed to the next slide. Has everyone understood on that particular part? Can I move on? Kindly put a thumbs up. Okay, I'm seeing Cecilia's reaction, so I beg to proceed. Okay, Jolie M. Okay, I'm happy that people are understanding. So to proceed to my next slide. So this is now the value of x. Don't come and write the 720 as a value of x. It's not. That is the determinant of x. For you to find the value of x, you divide the determinant of x by the major determinant, which is the first thing you obtain. And I believe we put a lot of emphasis and explanation into how to find the major determinant itself. So I'm going to proceed to the next to this slide. So we have now the value of y. How we find the value of x and how we find the value of y are not different. The only thing that changes is now the placement of the values. If you remember, or if yes, please. I'm seeing help had raised the hand. Okay. Help, if the question is burning, you're free to unmute and ask your question. Okay. Okay, just to proceed. So in this particular matrix, we're replacing the y values with the totals that we had, which were 340, 660, and 380,000. in the place of the y values. Because this is, like I showed you in the earlier matrix, these are the x values, all values under in this particular column are x values, all values under here are this particular column are y values, and all values under this particular column are z values. So we're now going to replace these particular values, or we're going to replace all the y values with 340, 660,000, and 380,000. So now the next thing we do, we derive the 2 by 2 matrix from the 3 by 3 matrix. We have 8. Yes, please, one young girl. If the question is burning, kindly unmute. One young girl, kindly unmute. Yes.
Thanks for the first part, but
Yes,
request that you
please.
summarize the next part.
Oh,
I
okay.
was
So I
trying-
just. Yes, please, one young girl.
All right, I'm trying to request that you summarize to the next part since you have had the first part.
Okay.
Yeah.
Noted. Thank you so much. Okay, thank you. So I believe, like Wanyange girls has shared, both of us have understood how to obtain the determinant of x, and we can still apply it to the determinant of y. The main thing I wanted to stress, particularly here, is now the change of values in the column of y. Okay, so that's why we have 340, 660, and 380 in that particular column. So of course, when you do the necessary workings, like I explained, you're able to get the determinant of y as 1,440,000 shillings in this case. So remember, I explained that this is, I've now just found the determinant of y. I have not found the value of y. So I'm going to divide the determinant of y, which is 1,440,000 Uganda shillings, divide by 2, which will give you your value of y as 20,000. So I'm going to proceed. If I'm going too fast, kindly let me know so that I can be a bit slower. Okay, same thing with the determinant of z. When finding the determinant of z, you're going to replace all the values under the column of z and put now your totals here. In this case, we have 340, 660, and 380,000. Yeah, 380,000. You create the 2 by 2 matrices. Subtract the major from the minor diagonals, multiply the value outside, and here we'll get the value, or our total determinant of z, as 2,880,000 shillings, right? So like I echoed earlier, we have just found the determinant of z. To find the value of z, we're going to get the determinant of z and divide it by the major determinant. The determinant of z is 2,880,000 Uganda shillings. We're going to divide it by 72, which will give us 40,000 Uganda shillings. So I believe we've solved the value of x, the value of y, and the value of z, and understandable to all unless otherwise. So from finding the value of the different variables, we found out together that the variable of x equates to 10,000 Ugandan shillings, the variable of y equates to 20,000 Uganda shillings, and the variable of z equates to 40,000 Uganda shillings. I.e., and remember, we let our t-shirts be the variable of x, we let our pair of trousers be y, and we let our pair of shoes be z. So the price of so now our price of a t-shirt is 10,000 Uganda shillings. The price of a pair of trousers is the selling price now is 20,000 Uganda shillings, and the selling price of a pair of shoes now will be 40,000 Uganda shillings. But remember, under the new curriculum, a conclusion is required after solving each and every number. So remember, we have just solved the first objective of this particular scenario, which is finding the selling price of each particular item, being the t-shirt, the pair of trousers, and the pair of shoes. So here it's very, very important to conclude, because the conclusion earns you a mark. So be very intentional in concluding after finding your values. Don't just stop at finding the correct values, because you'll be missing out on the conclusion mark. So here our conclusion reads: t-shirts should be priced at UGX 10,000 shillings, trousers at Uganda shillings 20,000, and shoes or a pair of shoes at 40,000 Uganda shillings. Since these values were verified against all the 3 days revenue records and can be used with confidence for restocking and pricing. So we have been able to achieve our first objective of this particular scenario by identifying the price at which the different commodities or the different items can be sold at, a t-shirt being at 10,000, a pair of trousers being at 20,000, and a pair of shoes being at 40,000. So we have completed the first part or the first problem of the scenario. Before I proceed, I kindly request that questions are asked, because the next objective will be away from this. Any questions before I proceed? Any burning questions? Can I proceed? Kindly let me know. All right, so everyone seems to be okay with the particular, yes, help. Help, kindly unmute and ask. Help, kindly unmute and ask. Okay, looks like help is not able to unmute, but let's continue. Oh, okay, yes, please help. Yes, hello.
Just asking whether if this is going to be posted on YouTube.
Yes, it is. We're recording this particular presentation, so you'll be able to find it on YouTube.
All right, thank you.
You're welcome. Yes, 111 kindly unmute and ask. 111 kindly unmute and ask. Okay, their hand is down. Thank you so much for those of you who are asking in the chat. I'm going to proceed to the next part of this question. Yes, Saint Lukwidi. Kindly unmute and ask. Saint Lukwidi, yes. Kindly unmute and ask your question. Okay, Saint Lukwidi, I think I'll get your question later on in completion of my question, or rather presentation, if you can't unmute currently. So I'm going to proceed to the next part of the objective, which is, yes, Saint Lukwidi.
Hello, good afternoon.
Yes, please, good afternoon.
Yeah. I would like to know, is there another method for solving this same matrix?
I kindly beg you repeat yourself.
Yeah, I would like to know,
Yes,
is there
please.
another method for solving the matrix?
Is there any other method of solving the matrix?
Yeah.
Okay, so like I explained earlier to the people on the call that had asked about the method I was using, according to the S.6 subsidiary mathematics curriculum, we ought to know how to apply and use Cramer's rule to solve 3 simultaneous equations. Now you can use the substitution and elimination method. They will still give you the same answers, but in the event that they present a question with 3 simultaneous equations, a candidate will be expected to use Cramer's rule, because I believe it's what the examiner will be testing, given that it's under, or it's expected of the curriculum to know, given the curriculum, given that it's under the curriculum. Have I answered your question? At St. Luke Widdy? Okay, Atiang Mary, kindly share or kindly echo your question. Okay, Atiang Mary looks to be.
Presenter?
Yes, please.
Yes, I beg that we shall respond to all the questions after you have fully completed the item.
Okay, thank you so much, Chair Stephen. All questions, I request that you write your question down. It shall be addressed. The next segment will be going through, and then the question shall be asked at the end. So, moving on to our next part of the question. Just to take us back to the scenario. So here, I've answered the first part of the question, okay? Finding the prices for each of the items. So now we're going to look at the second part of the question, which is this, okay? So we're going to read it together. The shop owner also received the arrival times in minutes after 11:10 a.m. of a random sample of customers over the same period as follows, and then they give us that particular data. Basing on the shop customers service policy, additional sales attendants should be deployed during the period when most of the customers usually arrive. Before implementing this policy, the shop owner would like to establish the selling price of each product and identify the period during which customers most commonly arrive at the shop. So keywords we should take note of are deployed during the period when most of the usual when most customers usually arrive, and also establish the selling price of each product and identify. So this is basically what they would like us to do. Establishing the selling price of each product, which we have, and now we're required to identify the period during which customers most commonly arrive at the shop. So moving on to the working. Okay, the customer arrival data, sorry. The shop owner also recorded that the arrival times of 60 customers. How do we know that 60 customers? When you count all the numbers here from the data provided, you're able to realize that there are 60 customers that were counted in terms of their arrival. So if you start counting 1, 2, 3, 4, you find that 60 customers were counting. That's why we have the above statement. The shop owner also recorded the arrival times of 60 customers in minutes after 11:10 a.m. So now to find the period when most customers arrived, we'll have to first start by arranging or organizing this particular data in a grouped frequency distribution or a frequency distribution table. Okay, so you can see here n is equal to 60. So the number of people, n being the number of customers, is equivalent or is equal to 60. So we're going to group them in a frequency distribution table, and we're going to use a class width of 5, starting at 15. Why are we starting at 15? Because if we look at our data here, we'll see that 15 is the smallest value. Yes, please. read one, we say that questions will be addressed at the end of this particular presentation. So kindly don't your question. So I've chosen to use a class or class interval or class width of 5, but you can also use a class width of 10, depending on what works for you. Class width of 5 and 10 are the best to use when grouping data under in the distribution table. So here we have a distribution table showing the given data. So this, like I mentioned earlier, each and every table or each and every diagram in mathematics should have a title or should be labeled. Now this particular title is a bit vague. The reason I wrote it there is to caution or to warn us as learners that we ought to avoid such titles. When you write a frequency distribution table showing the given data, yes, you have written the title, or yes, you have labeled your particular diagram, in this case being the table, but you're not going into detail, or the examiner does not understand which given data are you referring to. You need to be specific. So you writing such a title and saying, oh yes, I labeled my particular diagram, oh yes, I labeled my particular table, leaves a bit of question marks to what you're trying to imply or what you're trying to expand more about your table, or what's the content of your table. So it's very important you avoid or refrain from such vague titles. An example would This is an example of a vague title. The best title in this particular scenario would be maybe a frequency distribution table showing the number of customers and their arrival time. So now that gives an idea of the context or the contents rather of the table. I hope I've created or put appropriate or enough emphasis on that particular point. So now here our class, or what people usually put as our class, we're going to put arrival time. Please be intentional, and please be willing to read through the questions such that you're able to derive or pick out keywords. Because if you now come and put class here, yes, it's not wrong, but remember the class in this particular scenario is representing the what? Arrival time in minutes. That's why here one would expect to have class will have arrival time in minutes. So it's also important that you put units, because now you will leave the examiner assuming whether the arrival time is in hours, seconds. So it's very important that you put or bracket the units of the arrival time. So since they've given us data, like I've shown you, like we have seen here, we're going to have to tally to find frequency for each particular grouping under the given class width. So now here, remember we used a class interval, a class width of 5. That's why we have 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, 45 to 49, 50 to 54, 55 to 59. Okay. Now most of you might be asking, why did we stop on 59? The highest value we have here is 59. So our highest value here is 59, and our lowest value here is 15. That's why we've gone with 15 and ended with 59. Okay, so from telling, after telling, I to find out that from the grouping or the time arrival of from 15 to 19 minutes, we had 3 customers arrive. From 20 to 24 minutes, we had 4 customers arrive. From 25 to 29 minutes, we had 10 customers arrive. From 30 to 34 minutes, we had 11 customers arrive. From 35 to 39 minutes, we had 9 customers arrive. From 40 to 44 minutes, we had 6 customers arrive. And from 45 to 49, from 45 to 49 minutes, we had 7 customers arrive. 50 to 54 minutes, we had 5 customers arrive. And 55 to 59 minutes, we had 5 customers arrive. So now the frequency becomes the number of customers the number of customers that arrive at the different minutes or arrival times. Okay, so given our distribution table, it's very important that we have class boundaries. How do we now get this 14.5? Remember, when we're obtaining the lower class boundary, it's going to be now 15 minus 0.5, which will give us 14.5, which we have here as our lower class boundary for the first grouping. Okay, 15.5. Now here we have 19.5. How do we get our 19.5? We're going to get the 19 that's here, which is we're going to get 19 minus, 19 plus 0.5. So it could be 0.5, sorry. Yes, that's 0.5. That's why we have 19.5. So you do that for the rest of the classes to get their lower and upper class boundaries. Okay, so here I got the summation of the frequency, which is 60, which is basically the number of customers that entered that particular shop after 11:10 a.m. So now that we have drawn our frequency distribution table, we're going to proceed to finding the mode. Where are we finding the mode? If I could go back to the question. If I could go back to the question, you can see that they want us to identify the period during which customers most commonly arrive at the shop. So we need to find the mode or the modal time at which majority of the customers arrive at the shop. Okay, so when calculating the mode, we're going to so the mode is the value or class interval that occurs most frequently. When data are presented in a histogram, the mode can be identified by simply examining the height of the bars, which we're going to look at. So the first step is to identify the height of the bars. So you're going to compare the height of all the bars. Keep in mind the histogram is drawn as a bar graph without spaces in the middle, which I'm going to show you in the slide ahead. So one, you need to start by observing the heights of all the bars. You're going to compare the heights of all the bars in the histogram, and each bar, of course, represents the number of customers and their arrival time. Yes, and their arrival time. So you're going to identify the tallest bar, and you're going to notice that the bar representing, let me just move to the graph, yes. So you're now going to identify the tallest bar, which is the bar, this bar, which is now this particular bar, after drawing your histogram. So before even going to how to obtain mode from a histogram, I need you to note that when you're drawing any diagram, it requires a title. Like I mentioned, labelings in mathematics and numerics, and they are very, very, very important. If you're drawing a table, if you're drawing a graph, it's very, very important that you always label your diagrams. After labeling, or titling your diagrams, it's very important that you are very clear on labeling the different axes. Instead of writing class boundaries, it's important to write arrival time because it's what we had in our distribution table. Okay, and then instead of writing frequency, we're going to write the number of customers. So the number of customers will go on our y-axis, and the number of the arrival time will go on our x-axis. So you can see that the bars are together and there's no space in between the bars. So when identifying mode on a histogram, the first thing you're going to do is identify the highest bar and realize that this is our highest bar. On identifying your highest bar, you're going to connect now from this point up to this point. The lowest bar next to the highest bar, you're going to connect on both sides. Let me just fix that. There are joints. So on both ends, okay? The lowest or the lowest bars in between, rather beside the highest bar, you're going to connect the points from either end, and then at the point where they intersect, you're just going to draw a line to meet the x-axis. Okay, so from here is where you're going to be able to obtain the model or arrival time. The particular value you get from here is where you're going to get your arrival time. So I'm giving 5 minutes to any school or any individual that can draw a histogram for us and show us their workings and explain to us why they get the arrival time they get prior me sharing the arrival time I got and the results I got. So 5 minutes to the others, to every individual and school, to share their drawings of the histogram graph. As they draw, I'll be answering just two questions. I saw Ridwan's hand up. Yes, kindly unmute Ridwan.
My question is,
Yes.
because I'm just asking, in the scenario, we didn't see where they indicated for us to draw a histogram. What if one used the formula for finding mode?
You can also use formula for finding mode. That's if you're able to remember the formula, but I feel like the safest way to get mode is a histogram, because when using the formula, you're prone to making an error when substituting values into the formula. But the reason we use a histogram in this particular case, it's much easier to attain values, and there are less mistakes to be made as you fill in data compared to using the formula.
So do they carry the same marks?
I'm not sure, because
one that correctly uses.
I believe
okay.
if you correctly use the formula, the same marks will be allocated, unless the question restricts you to using a histogram. Yes, I believe I've answered your questions. Yes. Wanange girls.
Okay, this is Namra Dafin Kwagala from Wanyange Girls.
Yes, please.
When our school was answering that question,
yes, please,
that we did not use the
histogram
graphical method because it takes a lot of time. So it is better if we do it direct than you doing it with the graph. It takes a lot of time, which is unnecessary.
Okay. Thank you so much. Okay. Yes, please.
So use the calculation method
for the formula method.
Yeah. So you will end up getting the same answer very fast, and then you will save time during the exam.
Yes, thank you so much, Wanyange. There's also looking at time, but like I shared with Ridwan earlier, some people are prone to making mistakes when filling in values for the formula. It's, in my opinion, I'd say that histogram is safer. Yes, it takes time, but if you're able to practice and are able to manage your time well, I believe you will still be able to attain the same value. I don't know whether Wanange girls, you're willing to share the working you had for this particular number when you use the formula. Should I offer you sharing rights and you take us through how you use the formula?
Yeah, we can share the work.
Yes, please. Okay, so let me stop sharing. Okay.
Yeah.
Okay, let me do that.
Definitely.
Just go there, you'll get it.
See.
It is a manner if she has to be okay.
Okay, thank you so much, Wanyange girls.
Is ahead, so please. Yeah.
Okay.
So as you can look at that, it's the simplest way you can get the mode using the calculation method. Where you see our table really gives us what we want in the calculation method. So there's no need for us to use the graphical method. If you look at that formula, I can define the abbreviations there. There is Li, which is the lower class boundary. D1, which is the difference between the frequency before the model class and the model class frequency. D2 is still the difference between the frequency after the model class and that of the model class frequency, times I, the I you're seeing there in that method, which is the interval between the class boundaries. So since you already have the information needed to calculate this mode, you just need to substitute in. For example, Li is the 20, first we used an interval of 10. We used an interval of 10 when you are doing this class boundary. Our lowest class boundary was 29.5 in the model class. So you can see how we also got the model class, because you may ask me, where did you get it? We got the frequency divided by 2. That gave us 30 to get the model class. So to get the lowest class boundary, we use the model class row. We want the model class.
Wanyange, just before you continue, could you just scroll up a bit so that we could see the lower parts? Yes.
Okay.
What's that pattern? What is that pattern?
The model class.
Yes, please. Thank you so much there.
You just check in the frequency, the highest frequency. Lies with the model
You
class.
can continue sharing. Yes, please.
So, all right. Okay, I'll rectify the mistakes on the model class, how we got it. I think it was a mistake on how we got it. But to get the model class, if you look at the frequency column, you look for the highest frequency, and that is the model class. Class in the model class. It will show you that this time is the most common time that the customers arrive. So we use that row to get our lower class boundary, which was 29.5. The D1 was, I told you, I defined them before. We got the frequency of the model class minus the frequency before, and that was 4. And then for the D2, it was 18 minus 14, which was the frequency after the model class. So if you can see this, we calculated this thing and really got the answer rather than using the graphical method, which takes a lot of time. Yeah, to get the same answer. So I suggest use the shortest method, which we made the conclusion that the customers, most of the customers commonly arrived at the shop 34.5 minutes. It is after. It's supposed to be after 11 a.m. Hence the sales attendance can be deployed. So this is the simplest way we can use this method. We can use this method to get the correct answer, though they were just
Okay.
so
Thank you so
I
much. Oh, yes,
suggest
please.
I suggest that you use this method since we are
Mm.
we are running out of time. We
Yes,
have other
please.
questions to discuss, so you can use this
Yes.
shortest method rather than use the
Yes.
graphical method. Yeah.
Yes. Yes, thank you so much, Wanyange girls. I believe it honestly depends on what works for you. If you feel like the formula works for you, well and good. If you feel like a histogram will get the work done and will give you the appropriate answers, I believe you should stick with the histogram. Like I've said, time is really up. Though for your conclusion, I would advise that you add the 34.5 minutes to the 11 to 11:10 a.m. because that's when they start recording the time of the arrival of customers for you to make an appropriate conclusion. Yes,
Oh,
so I beg to have any questions prior my end of
okay.
presentation.
Okay. You've told me to make an appropriate conclusion.
Conclusion. Yes, please.
Yeah, conclusion. If I look at the question,
Yes, please.
okay, the problem was a writing error, but
Yes, please.
the right thing is supposed to be, they said,
Yes.
during the what? After implementing the policy, what? Customers must arrive.
Okay.
All right. Okay.
Yes.
I got that point. So
Yes.
additionally, sales attendants should be deployed during the time, during the period when most customers.
Is here. 11:10 is here.
Yeah. Most customers usually arrive. But then at the beginning of the question, they said in minutes after 11:10. So 34.5. 34.5 minutes. It's above, like it's after 11:10, right? But
Yes,
then
but
here is I made a rectification that this was a writing error too. Say that.
okay.
Yeah, 34.5 minutes to midday. It's supposed to be, if it was to be like that, it would have been 25.4 minutes to midday. That's right. That was the right way. But since it was a writing error, it's supposed to be 34.5 minutes after 11:10 a.m.
Okay, thank you so much. I kindly request that everyone that has a question, please present it before I end my presentation.
Present, I ask that you take us through your conclusion, and then anyone with a question, they can place them in the chat.
Noted. Thank you so much, Teacher Kaziba. Wanyange girls, could you kindly stop sharing so that I could share my PowerPoint?
Okay, stop sharing.
It's okay, you can share.
Okay. Okay. I believe you can all see my screen. So that's the expected conclusion. Let me just make it more clear. Sorry. Therefore, the shop owner should deploy additional sales attendants between 10:40 a.m. and 11:40 a.m. and 11:44 a.m. as this is the busiest customer arrival period. This will help reduce waiting time, improve customer service, and enhance the efficiency of the shop operations. So that was the conclusion for obtaining the model time of arrival customer. Any questions? Kindly, please put up your hand. Does anyone have a question? Okay. Thank you so much. That was my presentation for the first item under data and probability. Yes, I'm seeing Richard and Kabalega SS. Kindly unmute. Yes, please, Richard, kindly unmute. Sharia, kindly unmute.
Hello.
Yes, please, Mr. Richard.
Thank you, madam. I would like to know how we can get the intervals as we are given 15, 20. So I never knew how you got the interval.
I shared that you can use 5 or 10 to get the intervals, the class width.
Depends on what you want to use.
Yes, please. But 10 and 5 are the best to use.
Okay, thank you.
Yes. Yes, Sharia Mzee Davis and Samsung SM. Any of you can unmute and share? Yes, Sharia.
Good evening.
Good evening.
For me, my question is, yeah?
Yes, please.
This, when you are finding the mode.
Yes.
Do you round off or we leave the value like that?
I believe it's best to, in my opinion, I believe it's best to round off, because now in this particular case you had to add it to the time, and it's very hard to now add rounded off time. So I think it was better maybe to, let's say, 3.45 to now 35 minutes, so that you're able to now add it to the 11:10 a.m. to get the 11:40 or 11:55 time interval. Yes.
Okay,
thank you too. Yes, Muzei Davis. Okay, if Muzei Davis doesn't have anything to share, Samsung SM, the floor is yours. Kindly unmute and share. Okay, yes, Richard, your mic is open. Kindly share with us.
Hello, madam.
Yes, please.
I would like to know.
Yes, please.
If solid lines are recommended in determining the mode using the histogram, because I saw you using solid lines in prolonging to get the figure for the mode. Is it recommended?
I believe solid or dotted lines. I think, I'm not sure, maybe, but I believe if you use solid or dotted lines, both can work as long as you are able to get the accurate value of the model time in this particular scenario. Yeah.
All right.
Thank you so much. Samsung, we have not been able to get you, but I kindly request I end my presentation here. Thank you so much. You have been a good audience. It has been a pleasure. My name is Isabel Kembabazi from Taiba International School. And that was my presentation under data and probability. Thank you so much.
Thank you so much, Isabel, for the wonderful presentation. And thank you so much, everyone, for participating. I'm going to summarize a bit of some of the key issues that we need to pay attention to. Now, this particular item that Isabel has been working on, it is in section B. And when you look at section B, it is under data analysis and probability. Now, when you look at under data analysis and probability, in matrices, in senior 5 term 1, you learned about simultaneous equation in 2 variables and 3 variables. In 2 variables and 3 variables. So dear students, sub-math, we only teach you one approach of solving simultaneous equations of three variables. And the only approach you learn is the Cramer's method. And therefore, since this is under data analysis and probability, under data analysis and probability, we expect you to know how to arrange data in form of rows and columns. So the only suitable method you can use the moment you meet data, you meet a simultaneous equation, it is Cramer's rule. Don't think about the elimination. Don't think about the substitution. We do not teach substitution and elimination in three variables for sub-math. We only teach it in pure math, the other math of the other people. So please learn that under matrices, that's why they can only ask you things concerning simultaneous equations of three. And the only method we shall expect you to use is going to be the Cramer's rule. So make sure that you know it. And next time, even they can make it better. They can bring in issues of arranging them in rows and columns. So the moment you see that, it means that now they have even given you a hint that you must go on to use that approach. So that one I've cleared it. Then number 2, please specify what are you using to present your data. In data analysis and probability, we expect you to specify for us that you are using matrices, that I'm using Cramer's rule. I told you at the start, always identify what are you using, what are you going to, which approach, which method are you using. So I expect you that part of your communication, you are going to tell us using the Cramer's rule to solve the equations. So you specify that you are using the Cramer's rule. So that one, please pay attention to it. Under data analysis and probability, it is only Cramer's rule, not elimination, not substitution. Elimination and substitution can work under algebra, but not under data analysis and probability. Now, when it comes to descriptive statistics, what do we expect you? Now, we have basically three major central tendencies. We have mean, we have mode, and we have median. So someone who has done some math, we expect you that you know how to calculate mean, mode, and median. And the question may not ask you to calculate all, because those particular central tendencies, the moment you calculate, you'll find yourself getting almost the same answer. All the answers are going to be in the same range. That one. Then on top of this, we shall expect you to know what we call the measures of dispersion. That is the variance and the standard deviation. One of the items we have in there is asking you to calculate standard deviation. But you need now to know, what does standard deviation mean? Standard deviation, they are going to ask it in form of consistency, because for it measures how your values vary from the mean. So you'll find that in case a question is asking about standard deviation, they are not going to tell you calculate the standard deviation, but instead they are going to bring it that we have this particular data and this data. Are they consistent? Now, when it comes to consistency, then your mind should run you that here they are indirectly asking me to find the standard deviation. Now, when it comes to the graphs, we shall expect you that you know how to draw an ogive. We shall expect to know how to draw a histogram and how to use these graphs to estimate the mode, the quartiles, and the median, depending on the graph you have. So when it comes to histogram, we shall expect you that you can use your histogram to estimate the mode. When it comes to ogive, we shall expect that you know how to use it to estimate the median and the quartiles, or deciles or percentiles when you are handling those particular graphs. And please take note that when there are some things that make you sometimes fail. You may look at them as minor things, but they are very important. Number one is the title. Whatever thing you are doing, in case you are working on a frequency distribution table, please specify the method of presentation, that this is a frequency distribution table, that this is a histogram, this is an ogive, this is a matrix, this is using Cramer's. So specify How are you presenting your data? Are you using a scatter graph? What are you using to present your data? So please be specific on what you are doing. Is it a tree diagram? You tell us a tree diagram. Then label your presentation columns. I'm going to use an example. When we talk about labeling, please, the first two columns you derive when you are drawing your frequency distribution table, let those two columns come directly from your data. When you look at the scenario we have been doing, the scenario was talking about arrival time. There is no need why you come here and write class. This is not true. This is not what? True. So we expect that you are going to tell us that arrival time and where units apply. Go on and apply the units and tell us these are the arrival times are in minutes. Then from there, in case the question is talking about customers, then please write number of customers. Don't come and just write a frequency. What is that frequency? What does the frequency represent? So you go on and tell us in bracket number of customers and then you put F. Then from there you can now abbreviate, maybe in case you are finding F and the rest of that. In case maybe this particular item required you to find the mean, then you would have said the mid time. You don't tell us the mid value. You tell us the mid time and then you put what? X in bracket. Then that's when you can go on and have X. Avoid irrelevant columns. If the column is not going to work, don't put it there. So we don't expect now to draw the column of X, to draw the column of this. That's why it is always important to first plan for your data and what you are going to calculate. So make sure you know how to do an ogive, that always is a curve. So it must be what? A smooth curve using your free hand. In case it comes to a histogram, please never shade a histogram because we always use it to estimate. We always use it to estimate and avoid writing class boundary. What does the class boundary represent? Class boundary is representing the time. Then please be mindful of the language they use. Like here they use the most common time. You need now to know most common time. What does it mean? In case even they may ask you that the shop manager wants to see it graphically and use it to estimate the most common what time, then there that means that the only best approach to use is using a histogram for you to come up with your data. Now please avoid using formulas and symbols you are not sure about. Some of you, when it comes to, let me say, I've asked you to find mean, for you come and say mean. And you know what you write? You write M is equal to summation of f of x out of summation of f. This is wrong because M does not stand for mean. M can stand for gradient mathematically. So if you don't know the symbol for mean, do not use it. Write your word as mean. If you don't know the symbol for standard deviation, you write standard deviation. Don't write SD. Don't write value and the rest of that. Right, because each of these ones has a mathematical symbol. But if you are not sure about the mathematical symbol, please write the full word. And please take note that we do not award any score for the formula. No mark is always given for the formula. However, the mark is given for the right substitution in the right formula with the correct values. So look at the right formula, that you have used the right formula. 2, have you substituted in the correct values? That yes. In the right position? That yes. Then that's when you are going to be awarded. So in case for you, let me say, let me say you were calculating your mode. And someone, let me say you come, and then you have your class interval. And let me say, God forbid, instead of 29.5, and then here, I'm just using, for that particular data you have, let me say it was 11 minus 10, out of 11 minus 9, then plus 11 minus 10, and then everything times, let me say here, it is 5. And now for you, instead of putting class interval 5, for you put 10. Or maybe here, instead of putting 11 minus 10, you put something else. Everything becomes wrong. Because you have substituted in the correct formula, but the values you are putting in the formula, one of the values is wrong. So everything is going to be scored as 0. Because we only score a correct formula, correct substitution with correct values. Okay, now when it comes to the graphs, please make sure that your scale is consistent. You must have a scale that is consistent. Do not have a scale here. Let me say you have started from 19.5, then you go to 24.5, then here you put maybe 39.5. So you notice that here the scale is 5, here the scale is what? Is different. It is 10. So here you are not going to be marked correct because your scale is different. So make sure that when you go on to use the graphs, you have consistent scales. So what areas are going to be considered, or which areas do you need to look out for? Number one, never miss a title. That one is a free mark you should get. Number two, label your classes and columns very well. Always extract the wording used in the scenario to your table. Have consistent class width for the grouped data. Check out that the grouped data you are dealing with, the classes have equal class width. Tally correctly with correct frequencies. Make sure that your tally matches with the frequencies you have. Then have relevant analysis columns. Do not have those irrelevant things that you do not need. In case the question wants median, then please first ask yourself, what do I need for median? That I'll need a class boundary, I'll need the cumulative frequency. When it comes to the formula, list all the values you are going to substitute. Formula symbols, be very careful. I've talked about mean, I've talked about standard deviation and variance. Then make sure you substitute correctly with the correct answer. And now, like for the item we have been doing, I saw people were just writing 44.1 or 31.1. Now, this particular one has units. So I expect that you are going to come and write this in what? In minutes. Some of these things you are calculating have units. So put the unit of measurement. And then also you need to think, in case this time, I wouldn't expect to come after your calculation and you put very many decimal places and you leave your answer as this. If these are minutes, you need to know that what do you have? That in minutes you can have seconds. So I expect to write minutes and seconds. Maybe 31 minutes and how many seconds? Maybe these are 10 seconds. When it comes to the graph, specify with the title an ogive, a histogram, and this particular graph. Have the scale, determine the values, estimate, and show how you are estimating. In case this is a histogram, I expect that once you have identified that longest bar, please come. It is okay to use full lines. Come and clearly show that now my mode is at this point. But also please, I want you to take note that there are cases where you can have two modes, what you call a bimodal. You can come up with a graph and your graph is like this. So please here, we expect that you are going to get two modes. You'll come, get this, and then find a mode. Come here, get this, and find a what? The mode. So that one, you call it the bimodal curve. So it is very okay, or it is also very possible to find a bimodal. Now, when it comes to these sums, please write your sigma very well and put summation of f. In case the summation of fx squared, then place it there very well. So please pay attention. They may look a bit small, but they can cost you heavily on any item. Okay, now you are going to meet scenarios. In some of these scenarios, you are going to find that they have already given you the class limit. Please always check. Do not just jump out and say, let me now start from here. No, please check. What are you going to check? You are going to check that how are my classes? So you'll come here and ask yourself, check out these two digits first. Or allow me now to first, you check the class width. Between 19 and 14, is the class width the same? And then you say 19 minus 14, that here I have 5, here I have 5, here I have 5, here. So you notice that the class width is the same. The moment you find that the class width is the same, then that means that is very okay for you. So what next? You need to know now the class boundary can be obtained. So here you know that your class boundary will be 9.5 to 14.5. But now, please also take note, you are going to deal with things where the class you will meet a class of this nature. Please check out any of these to subtract 1.7 minus 1.5. What do you get? That you get 0.3. First check all the classes that your class width is the same. And now for such, we have something called the adjustment factor. Let me say, are you seeing these two values here? When you want to know how to deal with your class boundary, get these two values, 1.5 minus 1.4, divide by 2. So the answer you get will show you what you are going to subtract, and add on your class boundary. So here it is 0.05. So that means that here you are going to come and say 1.2 minus 0.5 to 1.4 plus 0.05, and then you continue. That is the same thing. That's the same way you can get. If you don't know how to get for this, you just get these two consecutive values. You say 15 minus 14 divided by 2, which is 1 out of 2, which is 0.5. That means when you are getting your class boundary, you will say 10 minus 0.5 to 14 minus 0.5, and then you get that particular answer. Then you are going to meet classes that are like this. You may meet, and when they are testing you, you may meet a class like this. Please and please, when you check here, you notice that here it is 5. Here it is 5. 5, 5. It is okay. The class width is 5. Now, please do not use cram work. Ask yourself, what about the class boundary? Now, when you check here for the class boundary, dear students, and you notice that these two values are the same. These values are the same. Already those values that have been given to you are class boundaries. So for that one, you don't subtract anything, because there, when you get these two consecutive values, 15 minus 15 divided by 2, you get 0 out of 2, which is 0. It means that you don't add or subtract. That means that those are class boundaries. You take them the way they are. So when you come, whether it is graph or whether it is a median or whether it is mode, you use them the way they are, 10, 15, 20, 25, like that. You don't do anything on those particular values. Okay, I continue. You are going also to meet cases of this nature, whereby they have put you less than, greater than, and the rest of that. Please also check out. For you, just subtract these two values. 20 minus 10 is 10. 10, 10. So you notice that the class width is what? Is 10. So what do you do? In case you are looking for class boundary, please always check out these two consecutive values. These values. The moment you check and you notice that those values are the same, when values are the same, what do you do? Please go on and see that if the values are the same, it means you just say 20 minus 20 divided by 2, which is 0 out of 2, which is 0. It means that also these values, you don't subtract anything. You take them the way they are. That your class bound will be 10 to 20, 20 to 30, and 30 to 40, and the rest of that. So please pay attention to those particular things. So the question can come, look easy, but you need to understand. Then there are times when you are going to find data like this. At your level, they may not give you any class interval to use, but I want you to know that when you are to choose a class interval, be mindful of two things. One, that whenever the best class intervals to use are 5 and 10. But you can use any class interval. But the class interval you choose to take on, please and please ensure that that class interval can generate at least 5 classes. If it can generate 5 classes and not more than 12 classes, it will be very good for you. What do you do? Always to check which class interval to use, whether to use 5 or 10, identify the largest value in your data set. For our case here, if I'm to look through to identify, one of my biggest value is 59 and the smallest value is 50. So what are you going to do? You are going to come and say highest value minus the smallest value. I test it with one of the class interval, divide by 5. So 59 minus 15, you get 44, divide by 5. So 44 divided by 5, you get 8.8. Now this one means that in case you are to use an interval of 5, you are going to generate 9 classes. Now, when it comes to the second one, 59 minus 15 divided by 10, it means you have 44 out of 10. So 44 out of 10 is 4.4, meaning here you are going to generate 5 classes. But I want to let you know that the smaller all these classes, all these intervals are okay, 5 and 10 can be good. But the choice is very important. Why? That if these classes you have generated using a small class interval are not beyond 12, I would always advise go in for that. Why? Because smaller class intervals always yield consistent values. They are more accurate than when you have a bigger class width but with very few classes. Some data is always taken within that. So someone who uses 5 and he has 9 classes is very accurate compared to someone who uses 10 with only 5 classes. So whenever the data, you need detailed analysis of data, please go in for small classes. If the data is large, is very large, then larger classes can work. So what happens? One of the disadvantages of these few classes is that some data is hidden within some classes. So you are not in position to see the variation in that data. So for this particular case or for this particular number, the base class interval that one would have used would have been 9. Here you could clearly see the data and how it is varying. So for someone who used a class interval of 5, you'd find that the time or your mode was around 31.16. Someone who went on and used a value of 10 as the class interval, your value would be 34 point something. Now you notice that this person of 31 is more accurate compared to someone of 34. So please always make the right choices. As long as your class interval, the classes don't go beyond 12, then please use a smaller class interval such that you avoid having data bias, such that you avoid having some variations that are hidden within that particular data set. So please take note of that. Now, okay. Allow me now to first end there. I don't know whether there is any burning question that I need to address, but I feel I have responded to that. Okay. Yes, Chibito SS.
Thank you, sir, for the opportunity.
Yes.
Now, my question is, assume we are handling matrices. Do we need to define rows and columns?
I would say it is very good. It shows understanding. You can define that this is a 3 by 3 matrix, or the order of the matrix is 3 by 3, and then the order of this is 3 by 1. So it is very, very good. It shows the understanding for the child. Okay, so you can define the order of the matrices. Sometimes the question may tell you, sometimes they may not tell you. Okay, someone is asking, why did you round off to 4.4 or something like that? Because like when you look at the variables you are dealing with is time. So when you are reporting someone time, you cannot say 31.4444. So time can the standard units are, you can have hours, you can have minutes, you can have seconds or microseconds. But microseconds are not easy to report. So that's why you say to 1 decimal point such that you match the seconds. Okay. Now, when you look at my screen, I've displayed for you. Today they have used the word most common. Next time they will tell you most frequent. Another time they will tell you occurs most often. Now you need to know the language being used whenever they ask you something. Yes, Endeavor SS. Wanyange prepare. Yes, Endeavor SS.
So the question is
yes.
about the scale.
About
the scale of the
yes.
horizontal and the vertical.
Mm.
About the scale,
Yes.
the vertical and the horizontal scale.
Yes.
Should they be the same or different?
They can be different. They can be different as long as they are consistent. That if on vertical you're using 555, let me say, you can find yourself now for this particular data using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The
Yes.
scale of 1. And here you can use 5. So they can be totally different, but as long as they are consistent.
Thank you.
Okay. Mzee Davis, the rest I kindly place them in the chat. I'll be able to respond. Because I want us to move on with Wanyange, and then I want to start off with other numbers. Common College?
Okay. Okay, sir. Good evening.
Good evening.
Yeah, I want you to help us in that part of bimodal. Are we going to use? Are we going to consider the two modes as the mode, or we are going to add and divide by 2?
You'll consider both. You write 2 of them.
Okay.
Yeah.
Okay. Thank you, sir.
All right.
Yes.
Okay. So allow me now to invite Wanyange. Wanyange.
Hello?
Okay. Yes, Wanyange, you can take us through the presentation.
To raise the voice.
We are preparing. Yes. Okay. So, good afternoon. My name is Naria Monica from Wanyange Girls, and I'm taking you through item 6. So, item 6, the question says, a telecommunications company operates 3 customer service desks labeled A and B, and C. Customers arriving at the service center are assigned to one of the 3 desks at random. The duration of the customer consultation T measured in minutes for a randomly selected customer is modeled by the probability density function that. So to improve customer satisfaction, the company wishes to determine the likelihood that consultation lasts more than 8 minutes. So I'm going to first deal with that first part because that's where the concern is. So in our solution, we have the defined. So we first defined the function as stated in the question, as observed there. So in order to solve the problem for the manager, according to the function, we have to first find the value of the constant k. So we first define the formula, which is the integration of fx dx is equal to 1. So this formula needs you to integrate. So this is how we integrated, and we finally got the value of our constant k as 1 out of 72. So after you getting your value, you have to replace it in the function that has been stated above in the question. So this is how we substituted in our value for k. So there we have not yet answered the question. They wanted the probability for a time that is more than 80 minutes. So as you're replacing it in the formula, here the limits have to change because the lowest time is 8 minutes. So that means for the limits, it will be from 8 to 12 because 12 has been given as the highest point. So after there, you have to integrate again, and that is how we integrated. So after integrating, we got the probability for the time, so let me repeat. So after integrating, this is how we integrated. So after integrating, you substitute in like that, where you substitute in the upper limit minus the lower limit. So after there, we got our value, the probability if the consultation time is more than 8 as 5/9. So you conclude that the probability of the consultation to last more than 8 minutes is 5/9. Sorry, we did not conclude it, but you can add it in your work. So that answers the first problem for the customer care manager. So we go to the second part where they say at the end of each consultation, every customer is randomly assigned to one of the 3 feedback forms labeled A, B, and C. So form A contains 1 positive and 2 negative. Then form B contains 2 positive and 1 negative. Then C, it contains only the positive ones. So each customer selects 1 response at random. The customer care manager needs to use the probability model. Each customer selects 1 response at random. The customer care manager needs to use the probability model to assess consultation times and the feedback data to evaluate customer satisfaction. So let me first go back to the response. So here, as you are interpreting the question, you have to know that first we have forms A and B. So for forms A and B, for a customer to pick any of the forms, it is at random. That means since there are 3 forms, for a customer to pick upon form A, it has a probability of 1 out of 3, same as B and C, because it is a random selection. Then, in the very same forms, for example, in form A, we have responses, as said in the question, where in form A, we have 1 positive response and 2 negative responses. But according to the question, they say that the customer has to be satisfied, like she has to give a positive comment. That means we are only going to take up the positive responses. The negatives are ignored. So that means the probabilities that we are going to find, for example, for a person to get satisfied according to form A, the probability is 1 out of 3. So as you're responding, you have to first let, for example, for us, we had to use unknowns, not to write very big statements. So we let the response in A, this RA, the RB, and RC, they are the positive responses. in forms A, B, and C, respectively. Sorry. So, first of all, you can use a table to represent your data. For example, in form A, the responses, we have 1 positive and 2 negatives. In B, we have 2 positives, 1 negative, and in C, all of them are positives. So we represented the probabilities of the responses. So for the positive responses in form A, this is RA, the probability is 1 out of 3. So for these following probabilities, there was a writing error, but it is supposed to be 2 out of 3 for the probability of the responses in B. So from the table, it is, if you are to observe in B, we have 2 positives. So that's where the 2 out of 3 comes from, because the total responses are 3. Then for C, all of them are positive. So it will be 3 out of 3. Then, if you are not well conversant with the table, you can use the probability tree diagram, where we have the forms A, B, and C. And we also have the responses, only the positive ones. We represented them as RA. Then for the negatives, the negative ones, it is R prime A or R prime B, like that, R prime C. So the probability of picking up form A or B or C, it is the same, which is 1 out of 3. That's why we stated it clearly on these 3 lines here that go to A, B, and C. Then we go to the responses in each form. For example, in A, we have the positive response and the negative response. So for the positive response, to get a positive 1, it is 1 out of 3. And in A, to get a negative 1, it is 2 out of 3. We did the same thing for form B and form C. You can also use the table to help you fill in the probability tree diagram. So after you drawing the probability tree diagram, it helps you to find now the general probability that is needed for the customer satisfaction. The total probability. So to get the total probability, you get the probability for the forms, for the positive response in form A plus the one for B and the one for C. Here you can interpret it as the probability of form A, if a person has picked up form A, intersection, because the responses are in form A, that's why we said intersection, the response, the positive response in form A. So also for B, it is the probability of picking up form B and having a positive response in form B. It is the same thing for C. So for this intersection is the same as multiplying the probabilities. And this is because these are independent events. One does not need, one occurs even though the other one is not available. So we multiplied the probability of picking up form A and a positive response in form A. So this is how we represented it even for other forms. Then, according to the different probabilities that we were showing you here, we were able to, you just substitute in for the probabilities that you've stated here. So we substituted in, and total probability we got was 2 out of 3. So in conclusion, 3 out of 2 out of 3 is the probability for the customer's satisfaction if the consultation lasts more than 8 minutes. So from my presentation, you are able to see that we have fully addressed the problems in the scenario and we've answered the customer care manager.
Thank you so much, Wanyangi. Can we have some few questions from Napak and Sheila? Unmute.
Okay, I'll receive the questions.
Hello, good afternoon.
Afternoon.
Yes, for the other one of the graph, the cumulative frequency. What if the graph has the bars of the same? Goes for the other question.
This is item 6.
Yes, because the question was for item 5.
I'm requesting for concerns on item 6.
I'm requesting for questions about item 6.
From there, we have no question.
Okay, thank you.
Intale, hi.
I was asking about how you got the value for K up at the beginning. I was just requesting for pardon before.
Okay. Okay, for a continuous random variable, these are continuous random variables, not so? So the total probability is equal to 1. First mute. I request that you all mute. Okay, so these are continuous random variables and the total probability is equated to 1. And this is the formula we use, which is fx, the x is equal to 1. And this is in the form of integrating. Whatever you're doing, it is integrating. So as stated in the question, it is kt. So that is what we were integrating. And k is the constant that we wanted to find. So from the question, the limits were from 0 to 12. That's why we wrote from 0 to 12. Yeah, the integral from 0 to 12. Then you know how to integrate. So we integrated. And after you integrating, you add a 1 and then divide by the new power. So after you replacing the upper limit and you subtract it with the lower limit as shown from our work. Then after there, you can find the value of the constant k. Is your question answered? Am I being heard?
I think it has been answered. Okay, we can have one question from user.
Okay, ask.
Or Sheila.
Good evening, sir.
Good evening.
Good evening.
Good evening.
Sorry. My question is, on this item 5, is it item 6? Where
Item
we,
6.
yes, where we're finding the probability. I beg you pardon, the table format that you use to find the probability.
Okay. So from the question, we had that for form A, we had 1 positive response and 2 negative responses. It is found here. We have 3 forms, which is A, B, and C. For form A, it contains a positive response, which is 1, and 2 negative. Then for B, it contains 2 positive responses and 1 negative. And for C, it is all positive. This is the very information that we fed in the table. As I'm going to show you. So for form A, we had 1 positive and the 2 negatives. Then for B, it is the 2 positives and the 1 negative. Then for C, they are all positives. As stated in the question, we just interpreted the question and represented it in a table form. Is that all?
Any other concerns?
So is there any other question about the table?
I think we can have one more, the very last question from Cavaliga SS. Cavaliga SS.
Yes. Unmute, please. Kabalega, please unmute and state the question.
Good evening.
Good evening. Good evening.
Yeah, I would like you to repeat for me the first part of the question, because you were over speeding. We never heard what you were saying.
Okay. For the first part of the
repeat and
question.
explain for me how you interpreted it.
Oh, how I interpreted. Okay.
Yeah.
So for the question, we had that for the first part, a telecommunication company operates 3 customer service tables labeled A, B, and C. Customers arriving at the service center are assigned to one of the 3 tables at random. So that means, for example, as you're going to a bank, there are different stores. So it is up to you to choose which one you want. So for them, they have 3 desks. So it is up to you to go to any desk that you want. Then they said the duration of a customer consultation T measured in minutes. So for a randomly selected customer is modeled by the probability function, the probability density function as shown above. So to improve customer satisfaction, the company wishes to determine the likelihood that a customer consultation lasts more than 8 minutes. So that's where we.
Yeah.
So the likelihood of a customer to consult more than 8 minutes is what brings about the probability. But according to the function that was given to us, we had a constant k in which we did not have the value. So we had to first find the value of the constant k, and that is what we first found. And since it is a continuous random variable, we had its formula as fx dx equating to 1. So in order to find the constant k, we had to use the limits that are used, which is 0 to 12. So that's why we wrote the integral from 0 to 12, and we are finding the constant k. So since it is the one we are finding, we had to first take it out of the integral. So as you're integrating, you know that from the power of t, you add a 1 to that power and divide by the new power, which is 2. So after you integrating, you substitute in the limit where it is the upper limit minus the lower limit as stated above. So after replacing in the limits, that's when you carry out you complete with the calculation, then find the value of k as 1 out of 72. So after you finding the value, you substitute it in the function that has been given to you. So that to proceed with the probability, so that you can find the probability for when the consultation is more than 8 minutes. So for the fact that they want the time to be from 8 minutes and above, that means as you're now integrating to find the probability, the limits will come from 8 up to the maximum, which was given to us as 12. So it is the integral of 8 up to 12. So after you identifying that, that's when you now replacing in the formula that was given to us. So that is how we so you substitute in for the function, the function ft, then you integrate and follow the same procedure and get the value for the probability. So have I been able to answer your question? So Kabalega, have I answered your question? Okay, thank you.
Yeah, you have answered me clearly. Thank you so much.
You're welcome.
Yeah.
Thank you so much, Wanyangi girls, for that presentation. Okay, you are going now to allow me. I'm going to share